these demos are not that interesting necessarily to see until you start thinking about how to make all of this happen. My name is Tyler Butler. I'm a software engineer, been in the industry for about 21 years now. I have this side project that I've been working on for a while called Beryl. It's a real-time channels abstraction for Gleam. So it's a system built for real-time collaboration using Gleam. So think chat rooms, think Discord-like experiences, anywhere where, or even Google Docs-like experiences on top of it, anywhere where real time is important. I have a professional history in distributed systems, and so I have a lot of interest in this area in general. And so Beryl is kind of my attempt to take a model that I think is the right model for this area, which is this rooms and topics abstraction on top of WebSockets, and make that something that you can write typed code against and have some safety with respect to your. So if I could take a step back for a minute, one of the challenges with existing real-time systems like Phoenix channels is that they are not strongly typed. And so you wind up with runtime callbacks that are not checked at compile time. And because they're runtime callbacks, they receive whatever they receive. And then, you have no guarantees that it's the shape that you expect, that it's the data you expect. So what I'm attempting to do with Beryl is fix that problem. So with Beryl, you actually have a type on your channel and you actually get that type back. And the compiler guarantees that when you are compiling, that data can only flow in that direction and is of the right type. I've gotten some feedback on the Gleam Discord about the specific approach that I've been taking to do that it might not be that Gleam-like. So that's an area where I'm trying to figure out, okay, what is the most Gleam-like model here? Because it's clearly not the Elixir model where Phoenix comes from, but and what I have right now is very Elixir-like, just with some type magic on top. But I'm starting to think about, okay, well, what does it mean to be more Gleam-like, where it's more like effects and it's a single update function that sort of handles all the messages. A lot of that model feels wrong to me and feels wrong to, I think, a lot of people when they first start looking at apps like Lustre or Elm. I think that there's a lot of value in trying to make the system you want, but use the language in the way it's meant to be used. And I think that's where I find Gleam to be a very interesting community. And I mean interesting in all the positive ways. They are very engaged. So I'll tell you a little story about the Gleam community. So I joined the Gleam community by writing some Gleam code and publishing it. And I published it publicly because that's what I do on every other ecosystem, of course. When you want to share something in JavaScript, you publish it to NPM usually. That's just what you do. And when you want to share something in Rust, you publish it to crates.io or whatever. So I did that. And then a few days later, the creator of Gleam himself came to my GitHub and made a comment, you claim that this library is type safe, but it's not actually type safe. I was like, oh my gosh, what? Like, I'm claiming something that's completely not true. And second of all, it's like the creator of C++ just jumped on my random project and gave me feedback that I'm not using the language correctly. And I was very, very surprised by that. And it actually caused me to get into the Gleam Discord and start having more conversations about, I obviously I was wrong. He was right. Like I wasn't using decoders properly and it actually wasn't type safe. So of course he was completely right. But what I learned from that is that, Gleam as a community they care a lot about the code that gets written. And, at the beginning, Jay, we were talking about this, care and sort of craftsmanship, I guess, in what we're writing. And I think that is demonstrated by the Gleam community itself, because if you go there, it's a bunch of people that are very interested in reading your code and looking at it and improving it, which is just kind of incredible from a community perspective. And the fact that the creator of the language is willing to give you some code reviews is just an amazing gift. It's an amazing gift to the community. I kind of wish that everybody that created languages had the time or energy to do that. But the fact that he does is tremendous. And I think that's something that really keeps me engaged in the Gleam community, actually, is that desire that they all have, it seems like.
Yeah.
So,
I find it really interesting or weird in many communities. It's not for me to tell how to run other communities, but you have a community that says we care about whatever quality or whatever, we care about this thing. And then somebody comes and asks questions and tells them like, oh, you're doing it wrong, just quit, don't do programming, or just don't do this, you're doing it wrong. And we don't want people like this. But like, how are you supposed to, like, if you care about quality, you should care about other people caring about quality. And if they're making an attempt to learn something, if you care about quality, you would care about them learning as well. But if you put in the like, oh no, you're not doing this wrong, goodbye, it's like, do you care about quality or just you care about yourself feeling like you are better than other else instead of caring about the actual thing you care about quality? Then I kind of agree. If you do care, you have to care about other people caring as well and make an effort for other when they try to make effort.
Yeah, and I would actually say that that whole experience made me take a harder, closer look at code when I want to publish it and share it in that way. It was just because I know that now when I publish something, he's going to be probably going to look at it, And so I actually, I care so much more about making that look good, be good, and, pass his quality bar rather than my own. And so I think in that respect, it's a tremendous thing from a motivation perspective too. Minor celebrity can really be a motivator. When someone that you admire or that you think is cool or doing something interesting takes the time to look at your stuff, that is just, it is surprising how motivating that can be. And that's, I think, one thing or another reason that people seem to like the Gleam community is because of that energy and willingness to criticize, but in a growth-minded way rather than in a, you're doing it wrong. You might be doing it wrong, but we don't have to say you're doing it wrong. We can say there's other ways we can say that.
You can say
exactly. Yes,
type-safe.
That really works for me.
I think I said this last time, so you can cut it out, Jay, if you want. But I think it's still interesting. I've only been on Discord and these kind of chat things in such niche communities, and I got used to people really being responsive and super intelligent people kind of telling you this is how it is and kind of giving you private tutoring there. And then at some point I went to some other Discord channels about maybe I was running my stuff on Bun or something, and you go there and then there's this forum thing and you kind of put your question into the void. So it's even worse than what Jay was describing. It's not somebody telling you, oh, it's stupid, don't ever do it again. It's just like nobody ever really answers anything, right? Because then you go through the other questions in there and you realize, okay, maybe that's like line 3 of the README, right? So that's how people are getting like, okay, not going to waste my time. But I always felt like these niche things as a hobby, they're much more encouraging than the big ones, right? There's lots of people, oh, well, why would I learn this? I can never get a job in it. Yep.
I think that's a trap that people fall into. I mean, Jay and I were kind of talking about it at the beginning, like this marketability of the skill that I'm learning. Like, if you're only learning marketable skills, what a sad existence. Like, I mean, there's so many things to learn and so many things to do that aren't marketable, but that are worthwhile. I think sometimes especially when we think about jobs and making money and everything, it's easy to get trapped by what is popular or what is marketable. But I would argue that I've learned more about distributed systems from doing this side project because I did it from soup to nuts than I learned from 5 or 6 years doing the same thing professionally, just because professionally my scope is much more narrow. And with the side project, I actually tried to build it from the ground up into something that was usable. And that's just much, I had to learn a lot more to do that than I do at work where my scope is just more narrow.
Yeah, and also, where did you fall off the wagon if you do it because it's marketable? Because I mean, a lot of you went through computer science, right? Like, you were never marketable as a person in social life, right? Like, keep doing it. That's what we want, right? Like, be a proper freak, right? Learn the weird language. So I'm curious, what
Yeah,
do you
yeah.
have to
So,
show?
so
I'm
I was
curious about Gleam
I thought I could show a
on the
couple of
back end.
demos because I think that that's where things get most interesting. So there's a URL you can go to, and I've got two demos set up there. The the first is a cursors demo. So if you just want to click through the cursors, you can choose a display name. These demos are not that interesting necessarily to see until you start thinking about how to make all of this happen. So what's happening here is that all of us are connected to individual WebSockets. And then as our cursor moves, messages are sent from that WebSocket and then get rebroadcast to all clients that are connected to all the other sockets. So there's essentially three processes here, three Beam processes that are running, that are managing these cursor movements. And this is honestly, like, these two demos represent what I call the 90% case of presence in real time. Like, most presence in real time is about displaying when you're typing, displaying real-time cursor movement, and displaying who's online. Those three cover 90% of what you end up doing with collab tech. And it turns out that presence is actually kind of a tricky problem. Let me bring a demo of presence and why it's tricky, because I think that's an interesting thing. So here I've just put this little demo together to kind of demonstrate what's challenging about presence. So imagine that you have two nodes, and these are like machines in a data center or VMs that are accepting requests. And so you have this message that comes in from a user, Alice, and she's joining. And so she joins node A, and there's a message that gets sent to node B that says, hey, Alice just joined. Everything is great. But it doesn't actually work, because imagine that this happens. So the Wi-Fi goes down, Alice drops off for a second, but her client reconnects, but then she lands on a different node. And so now this node broadcasts a join, and the node that Alice was on, node A, broadcasts a leave. But there's a network hiccup and the leave gets delayed. So the join to A goes, and then the leave comes in to node B, and Alice drops from node B. So now we are out of sync. And there's another way that this can happen. Imagine that node A goes down. We've got two users connected. Node A goes down. No leave events ever get sent. So now node B shows Bob and Carol forever. Like, they're just there because no leave events were ever sent for them. And so to fix this, you end up having to write, heartbeats and monitoring all of that. And that just, it ends up that that's not any of the logic that you want to be worrying about in your own app. So the way that Beryl solves this is the same way that Phoenix solves it. And it's with a CRDT. Critical things about a CRDT is that it is a data type that is idempotent. It has a merge operation that is commutable and idempotent, and what I can't remember the other term. It means that you can merge changes from these data sets or from these data structures in any order, and you wind up converging to the same state. So if we make a small change to how we do this, we'll see that it'll start working, and we'll converge to a consistent state across both nodes. So we've got Alice, but you'll notice that this time we tagged Alice with an A1. And so Alice gets this little ID, and we know that broadcast is coming from A1. And now we see that Alice leaves node A, the Wi-Fi blip happens again, and the leave event gets sent, the leave message gets sent, but you'll see that it notes that it has observed A1. So we call this add wins CRDT. So that means that the leave is tracked, but it will only leave things that it has seen. So we'll see what that in action. So the join comes to node A. Alice is on node A again, but it's with the tag B1 this time. And then we see that this leave comes in and removes the A1 because it had seen the A1. And boom, now we're back in sync. And this CRDT allows us to essentially solve the presence problem just by shuttling around deltas of this one data structure. Formally, it's called an adwins observed removable set. That you can look it up. I won't go into more detail about it. Curious if you guys had any questions or if that made sense.
It made sense so far. I'm wondering about the node crash though. How does that?
The problem with the node crash is that there are no leaves that ever get sent. And so there is this process in Phoenix and in Beryl of heart beating. So the system itself, in addition to the CRDT, is consistently sending heartbeats and expecting heartbeats from connected clients. So and that is configurable, I think. So you can say, like, I want to send my heartbeats every 30 seconds, and you essentially control then the latency that the maximum latency that your crashes can create. But you're right. Like, the CRDT itself does not solve missing messages. It only solves when we get them out of order, are we converging to the same state? So the other piece of the puzzle is that heartbeat that ensures that there's essentially a sweep that is coming through and sweeping out dead connections. But I like this example because it sort of demonstrates how the naive solution, which is totally workable in non-distributed systems and will often work when you're testing, will not actually work in production in a real world scenario. And that in and of itself is why I find distributed systems so interesting, because they're hard to debug, they're hard to test, they're hard to reason about logically. So they're mentally challenging. So I enjoy that aspect of them. I'm curious if you guys are interested in talking a little bit about the sort of history of the Beam and why I think it is a good fit for these sort of apps.
Yeah, also maybe a bit about how it works, I guess, right? I mean, like the Beam, not necessarily like down to the bone, but I think it has these actors.
Yeah.
Right?
We'll just add to the pile. And in this case, in the case of Beam, is node kind of one process, or one node means one node? Like, what's the how does it?
Yeah. So I'll caveat all this by saying that I'm a Beam newbie, and so I'm learning as I go. My understanding is the Beam has a very different architecture than other runtimes. In particular, I mentioned when we were doing the cursors demo that there's this one process per connection. And in any other system, that would be a little bit nuts. But the Beam was kind of designed from the ground up for this model. And it even predates the web, which I think is interesting because it fits the web so well. It predates the web, but it comes out of telecom systems. So Ericsson had, telecom systems in the 80s and late 70s, and the requirements were pretty brutal. You've got millions of concurrent connections. Each one is dedicated to a conversation, a real-time conversation that someone's having. The hardware could fail. The connections were not stable all the time. And they also wanted to be able to do in-flight software upgrades. So, being able to patch the software while it's running, which I've that's just crazy talk to me. Like the fact that they were thinking about doing this, back in the 80s and 90s, it's crazy to me. But they did. And so the Beam, if you think about it, if you've got 1 million individual connections that are having a real-time conversation, that sounds an awful lot like a real-time WebSocket that's, passing data back and forth and is stateful. And so the way that they did that, the way that they implemented that and built it was with a VM that makes processes very, very cheap. So processes are only a few KB on the Beam. And so you can have millions of them on a single node. And so you ask Jay, what is a node? My understanding is a node is an instance of the VM, but it is not a process. So I think you can run multiple nodes on a single machine, but it is not a process. The nodes house the processes. And there's an apocryphal story. I don't know if it's true, but apparently WhatsApp, before they were acquired, ran 2 million simultaneous TCP connections on a single Erlang node and had headroom.
I think I heard when they got acquired that they were on 6. They had like 6 machines or so to run all of WhatsApp.
Yeah.
Which just
so I guess my dream when I think about that is, what if I could build the equivalent of a toy app, because it just runs on one machine and it doesn't really have to think about all these distributed systems problems, because the combination of the Beam VM and the Gleam language give me the confidence that I can write something, compile it, test it, and then know that it's going to run at scale in that same way. I think that's kind of the promise of Gleam. I mean, I think early on, the website might even say it, helping you build systems that scale. And I think that scalability comes partially from the language, but also partially from the Beam itself and the capabilities that it has. I mean, it even has built-in storage and a built-in database like distributed systems database that you can use that's just built into the runtime. So, 10 years ago, I wouldn't have thought that having something built into the runtime or to the language itself is so valuable. But in 2026, with supply chain attacks and dependencies are this huge challenge now, we're all thinking about how do we minimize our dependencies? How do we control our dependencies better so that they don't, destroy our systems? And so I think it's interesting to think that there's this system hiding that you might not know about that actually has a bunch of stuff built in that you don't have to take dependencies for. And there's this language now that makes it actually palatable and writable. Yeah, so that's my view of the Beam from a distributed systems perspective. I think it is worth noting that Beam nodes are all trusted. So there's no, like if you cluster nodes in Erlang, they're all trusted. And as far as I know, that's not something you control. So I think there's some devil in the details there in terms of deployment, like when you deploy these things. And that's where, I hit my limits from a hobby perspective. I want proof points that the system scales and is usable. And in the Gleam Discord, they use this term production ready. And I don't quite know what it means to claim production ready of a side project. I would like to be able to claim that, but it feels disingenuous. The best I can say right now is that the API is pretty stable. But yeah, this production ready, like how do you actually get that with a side project and an open source project? One way I've been trying is there's a guy in the Gleam Discord that I met that is building a online community system that's kind of like a combination of Discord and old school forums. And it's pretty cool. It's called IRD. So this site IRD is built by another guy, and he's using Beryl for the real-time features. The rest of it is not built on Beryl, but the real-time features are. And I encourage folks to, if people are interested in real-time or in Beryl, to use this community as a place to go and learn more and ask questions too. So I've got a documentation page up at beryl.tylerbutler.com, and anyone is welcome to view that and look at the source and file bugs, ask questions. I'd also encourage people, if you're interested, get involved in the Gleam Discord. It is a really cool place, and I'm there along with a lot of other people that are building cool stuff. So it's a good place to hang out. And then there is the AirDay community for Beryl, which is a good place specifically for questions about it or projects using it, et cetera.
I mean, there's something on .com, so it is production. Like somebody has it in production. So it's production ready as a chicken and egg. Like somebody needs to be first into production, and after that, it's production ready, right?
It's one reason I don't really like that phrase, because I just don't think it means enough. Like, I think when you say API stable, that means something. Okay, the API isn't going to change. There may be bugs, but the API is stable. And you can say it is in use at these places, or, it has, and eventually maybe you get to the point where it's like, 5% of the Fortune 500 trusts Beryl as their real-time gateway, but getting there is a little bit tricky.
I think production ready is a useful term for you to assess the confidence of whoever claims it, right? I think that's all it really tells you about. Because some people are just going to say that from day one, right? And other people will say that languages, programming languages that have stuff like null that isn't checked are production ready, whereas I would kind of argue that
That is
maybe
a
not.
really good point. Like,
So,
once you start
yeah.
talking about specific languages and pitfalls that they may have, like deciding whether or not to use a JavaScript or TypeScript term, like what ESLint rules are required for production ready? Like, define for me what about the language I can and cannot use to be production ready.
Yeah. Also, Mark and I were fans of PureScript, and we used it successfully in multiple productions. And a lot of people successfully use it. There are people who use it on the Erlang, on Beam as well. They compile it,
Wow.
and it's like more experimental than experimental because it's not as known, but people use it
Yeah.
successfully as well.
Can you tell me a little bit more about it?
The interesting bit is, I think, one of the few companies that's still left that uses this in production. They're using the Erlang backend, and they're doing some crazy streaming for Disney and so on.
And I think that might be a little bit of Gleam's superpower, is the familiar syntax. It's still different. I particularly like the pipe operator, which I know for people with functional programming backgrounds, like piping is just, not that interesting, but I'm like, whoa, that's crazy. It's so cool. And it makes for really interesting API designs too, when you figure out how do you structure your APIs so that pipelining works well and makes sense. So while I don't nerd out as much about the functional programming side, I do like the language and API design side, and that's where I think it comes down for me.
I think syntax is really nice, but you don't get there so easily if you're used to like C or Java or whatever. But you're probably used to getting that stuff quite easily, right? If you go from Java to Python, probably gonna, okay, maybe it doesn't have braces, but the way you think about things is also different. And then if there also is the whole syntax thing, right, then that is a lot of the times I think it's too much at a time for somebody who is not willing to, sit down for weeks maybe and do that stuff. And since most people do that in their free time, it's just hard to get people who don't have any specific reason to really like that stuff to go there. And I think for Jay and me, we wouldn't have gotten there as a first step, right? So for one thing, I think some people back in the day from JavaScript went to Elm and were quite excited about that. And that has almost the same syntax as Haskell, but less crazy stuff and great error messages and so on. So it's a really good gateway drug. And then kind of if you want to go through the concepts, I could also imagine people first going to something like Gleam or in our case, Scala, right? So you do Scala and then you learn all these things, you find out about all these functional things, and you can kind of slowly learn them because you can still do object-oriented or whatever stuff that you feel like doing, and then you can slowly learn it. And we got to a point where we're like, okay, we don't actually want all the rest anymore. We only want to use that functional stuff. And it's not that great at inferring types and so on. So you have to annotate a lot of stuff still. And at some point you're like, yeah, let's just use Haskell. And then we tried and then we compiled it for a bit and we're like, okay, let's use PureScript instead. And that's kind of how we ended up with that.
I'm not sure if it's a stupid question we don't need to go into. But with CRDTs, you have to make decisions on how you're going to deal with conflicts, right? Like, as you mentioned, you have to decide if the leave going to win or the join going to win. And I assume for different entities or different levels of your app, you want different CRDTs. right? And they could be different, or usually have like some one super powerful CRDT.
If you're writing an app that's like a real-time collaboration, document editing type service, then you would have multiple CRDTs. Presence as a problem only needs the one. And CRDTs are like, they're kind of magic in that you don't have to think, they encode their merge logic in the data structure itself. So you, by choosing your CDRT, or CRDT, sorry, you are choosing your merge behavior. So that's why there are at least two maps in CRDT land. There's the observed removable map, and then there's the last writer wins map. And so they have slightly different semantics around how they merge, and that's why you choose one versus the other. CRDTs are like any data structure in that you have to choose the right one for the problem at hand, and if you choose the wrong one, then you know there lies pain. But yeah, I think the presence in particular only needs the one.
I suppose there's also times where there really is, where there's maybe only heuristics, right? So I'm thinking of like 5 people editing the same sentence at the same time or something like that, right? I don't even know if there's a correct way, even just if you wanted to specify, right? Like where should you put some text ideally, right? So I guess at some point you need some tiebreakers and just kind of say like, well, okay, we just do whatever you said, right? Like maybe we just take the last one that came in and we stick it here.
Yeah, CRDTs are interesting because you end up having to make some decisions about what happens when things happen, quote, at the same time. Even though that's really not true, it just means that something happens before, like time is always a factor. So even though things might happen instantaneously, there's still latency that you have to deal with. And CRDTs kind of make it so it's almost like if you choose the right CRDTs, you don't have to think about a lot of the, like with Beryl, all I have to do is broadcast the deltas from the CRDT and then merge those deltas in. And I can trust that is always going to converge. And yes, every node or every person might have a slightly different view of the world for a period of time. But I know, and I can prove mathematically, because it's CRDT, that they're going to converge to a known state, which is kind of what the demo is showing. Like, yes, there is a time when the second node knows about Alice twice because Alice has joined twice. But what we can also say confidently is that we know that Alice will eventually converge to only being shown on the right place. And we know that that can converge within a certain period of time, given the latency of behavior of our system.
Yeah.
I'll walk through this code real quick. I worry about showing it only because the API is changing, because I got feedback from the Gleam creator to lean more into the Gleam patterns. So I'm trying to figure out how to do that. So these are changing. So this is just starting up Beryl. There's a pluggable codec. This is really key. So while Phoenix is what I talk about a lot, and the main transport, I deliberately designed it so that you can plug in any transport and any codec. So I've successfully used Beryl with Socket.io, for example, which just uses a different framing than Phoenix. And then you register your channels, and you basically say this Mist transport handler, and Mist is just a web server for Gleam. The way this works is you compose your Mist handler, and then you say, I want to handle the WebSocket path this way, and I have this HTTP fallback. So if any request comes in that isn't a WebSocket request, it has this fallback that it goes to. Second part, this is the part that is changing, but is the crux of the real value proposition of Beryl. In Phoenix, it has a system like this where you create these callbacks, but they are untyped. And specifically, these room assigns, they're called assigns, but it's basically the type that your channel is carrying across to all of the connected clients. And in Beryl, this becomes strongly typed. You create the room assigns and you create the model that gets sent. So you can set whatever properties and whatever things you want. And then you create that channel and you give it this callback. And at the point at which your channel gets called, then we know at compile time that is the type that you expect it to be. And so you can be more confident than, say, in the Elixir world, that your callbacks are going to be working with data that you expect. So theoretically, there should be a lot fewer runtime crashes and runtime things that you would need to deal with. That in the Elixir world, perhaps there's a lot more defensive coding around that you wouldn't need to do here. I like this API. I really like it a lot from a consumption perspective. What is disliked about it, I think, from the Gleam perspective, is that there's some type erasure going on here. The assigns get type erased into this other sort of dynamic type, and then they get unerased at the boundary again. And I do a couple of things to make sure that is as safe as possible. For example, like I create a unique ref and then pass that ref along, and then the receiver checks that ref matches so that it knows that the type that created, or excuse me, the code that created this is the same code that's reading it, and things like that. But I think the reaction has been, that's not the right approach. That's not the right Gleam approach. And so what I'm wrestling with is, I love this API. How do I make it possible to do something like this without a heterogeneous registry of channel types? And that's what I'm working through right now. And where I've landed is that it's, instead of the library dispatching to the channels, the routing lives in the app. And why I don't like that is because it's a lot more app boilerplate that you have to write on the app side. Boilerplate's fine. That's fine. Like, it's understandable code or it's simple code. It may be verbose, but that's fine. I think I have to fight my own urges there to figure out how to make it work without a heterogeneous registry, but still have an API like this, because the API now without the registry is it's a lot harder to consume, in my opinion. This is 3 functions and you're good to go. So anyway, those are the things I'm wrestling with. In case anyone is watching and has a lot of Phoenix experience and Gleam experience, I would love to chat with you. Because that is where I find myself right now. I don't have enough Gleam knowledge to figure out the right thing to do, and I don't know Phoenix enough to engineer the way it works into something that would work well for Gleam. But that's why side projects are interesting, because we don't have all the answers and we're learning them as we go.
So you can compile it to both JavaScript
Correct.
and Erlang, right? So would you then, with Beryl, do I share code that you can use in JavaScript?
Not in Beryl itself, because it takes so many dependencies on the beam. Each connection is a process on the beam, and it leans pretty heavily into actors and message passing between them. So it is clearly designed for the beam. But the reason I wanted Phoenix wire compatibility is because you can use the Phoenix JS client against Beryl, just like you would against the Elixir server. And I wrote a Beam client called Aquamarine that you can use to write Beam tests against Beryl. So you want to write your tests in Gleam, but still, still actually test the WebSocket stuff. You don't have to do that in JavaScript. You can do it in Erlang as well.
So the demos that you showed us, they're written in JavaScript?
The client side part is written in JavaScript. The server side part is written in Lustre. Okay,
so that Lustre, and then that goes to a server.
Beryl is running inside of Lustre.
Okay, nice. Or you could have written the front end in Gleam as well, right?
The challenge there is that I actually have done this for a different project, have cross-compiling Gleam that runs in both the server and in the client. The challenge there is that the shape of things like when you start something in JavaScript, like it's always async and it returns a promise. And so if you want to call into a JavaScript API of that shape, as far as I know, the way you have to do it is you have to create some foreign function interfaces for both JavaScript and Erlang. And then when it compiles, it uses one or the other. to interface with those languages. The challenge comes into, well, so I make a fetch request, or so, how do I make a fetch request in Gleam that will cross-compile to JavaScript and Erlang? As far as I know, there is no way to do that right now. So if I want to have Gleam code that compiles to JavaScript that can then talk to Beryl, it needs to be Gleam code that can make a WebSocket request with a particular shape. And in order for the JavaScript client to make that WebSocket request, there has to be some sort of Gleam API that I call that then gets translated into the appropriate Erlang and JavaScript APIs when it's compiled. And so I need to be either using the Gleam standard library or packages that are dual target, so that are already targeting JavaScript, or I need to build that FFI that tells Gleam how to compile or how to interface with that external piece. And so if you think about using a web API like Fetch or even the socket connection stuff, there has to be some bridge on the Gleam side to those APIs, and they don't always exist. And such a bridge can't always exist because of the differences in how the actual platforms, the Beam versus the JavaScript VM, just basic differences, fundamental differences, I should say, in how they operate. Async, I think, is the most interesting one. Like, if you have an API on the web that returns a promise, and the similar API in Erlang does not return a promise or is not async, how do you have a Gleam API that is cross-target for both of them?
I think it's going to be tricky to build a browser in Erlang first.
Yeah, I think if you come from the browser side, and there's this other question of like, so Gleam compiles to JavaScript. So you would say, okay, if I write my CRDT library in Gleam, then I should be able to compile it to JavaScript and just use it as a JavaScript package, right? Well, yes, but no. This isn't necessarily something that Gleam says don't do, but it doesn't necessarily make it easy. And one reason is because Gleam has things that JavaScript doesn't, like result types. And like, how are you going to model those APIs in JavaScript? Well, the way Gleam models it is by having JavaScript result types that it compiles to, which is fine, but it just means that, it's not as simple. It's weird JavaScript. I think it might also be weird Erlang. Like Gleam might produce weird Erlang and might produce weird JavaScript too. I don't think that's a problem, but it hurts interop a little bit. My take currently is that that's just not a goal, and I'm not convinced it should be. I think the Luster model is the one that the community is chasing and is probably the right thing. And for that, the model that Gleam has works well. Like, you can have true code sharing, and it runs in JavaScript and in Erlang, and you don't have to worry about it. And, we were talking about PureScript and performance. Like, I don't know how Gleam JavaScript performs compared to vanilla JavaScript.
To defend PureScript here a bit, there is an optimizer for it. And might be the same thing for Gleam. You can actually sometimes use this weird JavaScript to your advantage, right? So you can actually, if you never really want to read this stuff, you can produce output that is actually faster sometimes, right, than idiomatic stuff, because, you could write really weird stuff, essentially, right, that nobody would write otherwise. And you can inline lots of things, right, that you would hope maybe the V8 or whatever you run it on does for you. But it can sometimes, I guess, at least in theory, become some advantage. Say that JavaScript is the assembly of the web, right? Like, nobody really writes any JavaScript anymore anyways, right? Even if you write TypeScript, it still gets kind of just compiled down to JavaScript. So maybe there is something to be made here, but oftentimes I will agree that, especially in these functional programming circles, these things are left as an exercise to the reader.
But we also know that V8 likes types, right? Like, we've seen that if you align things in a way that is going to optimize, that TypeScript is often also faster than JavaScript, just by the way. It knows things that it doesn't know otherwise.
Yeah, and you have some tree shakers, right, that can remove dead code and so on, and you can put like some annotations
Mm-hmm.
saying pure there, and it's gonna like optimize stuff really well then because it can rely on lots of guarantees. And if you do that with PureScript, I mean, it's in the name, right? Like everything's just annotated pure, and that potentially helps as well, right? But I mean, there's probably always ways to like handcraft some super
This
fast code
conversation is making me
in
realize that
JavaScript.
there might be an opportunity for me to get deeper into Gleam's JavaScript compilation story and contribute a bit to that, because I do have some experience in that area. And I'm hitting against the FFI problems and cross compilation problems through my projects. So maybe I can jump in there. And I'm always looking for ways to contribute more broadly than I am currently. So that's a really cool idea.
Maybe we'll look at the chat demo. And does it
Yeah,
use like different CRDTs or different code or different problems compared to the presents, or it's quite
nope.
similar?
It turns out it's exactly the same code and the same problems, just applied to a different
See, I mean, even if you
case.
just said that, it's kind of interesting to know.
Yeah, let me share it here.
You mentioned in the beginning, but what sort of problems and collaborative things you could cover with Beryl? Like, is it, we've seen courses and chat rooms, but what other problems? You mentioned that you can do Google Docs and chat rooms, but does the API allows you this abstractions of rooms and things just allows you to do anything pretty much, right?
Yeah, it's a very fundamental abstraction, and it comes from Phoenix and other projects that have led the way here. And that's one reason I think it's a solid abstraction. I call it the right one because I don't know of anyone better, and I certainly haven't tried to come up with a better one. I really do think it's good. I think that almost anyone who is using Beryl for something beyond a website or an app, like for real-time features, would probably build on top of it and create an additional messaging system, or build in their own transport, for example, if they wanted to have more control over the wire shape. I have a separate project where I'm building a collaborative document editor. And for that, I'm using CRDTs and Beryl as well. But the use case is completely different, and I'm building on top of Beryl as kind of like a baseline, but I'm building richer messaging and things on top of it. So I tend to think of it as not the lowest layer, because it's helping you put a vocabulary on top of WebSockets. So it's not at the lowest level, but it's right there in the middle and can be built directly into an app, but can also be part of a library that was building a higher level sort of like document collaboration type service.
Is there a CRDT library?
I built one called Lattice, Lattice. It's published on Hex. Yeah, so we can show the chat room demo. One thing you'll notice if you switch rooms and then go back to the room that you were in, that it goes like the data is lost. And that's intentional because it's demonstrating that there is no persistence of this presence data. It is ephemeral. And so if you want persistence, like that's when you start talking about document collaboration, where you're working on docs together, like you care about where the data is going and how it's stored. That's something that Beryl doesn't have to care about. Like Beryl's data is by definition ephemeral. And
I just tried what you said. You were right. They were all gone. Nice. This is always exciting, I find. I was building something a bit like this at some point, and I found that I missed a lot of bugs because I always tested it myself in like two different tabs or like two different windows. And it was all fine as long as, everything was happening one after the other. But as soon as I was doing it to somebody else and stuff was moving at the same time,
it is
it like kind of really...
one of my favorite distributed systems bugs is you want to try and count something. And so you have two people and they're just, writing down a number of how many people they've seen. And if you store that value in a map as just a value, then you'll start missing things, because someone will say 41 and then someone else will say 42 and then someone else will say 40. And well, you've got to decide how to take all that data and make sense of it. And to your earlier point about choosing your merge behavior based on CRDT, part of that is deciding what the user intended, like what was the intent of that action that they took. Yes, we have our data, and yes, we can merge it in a way that will be deterministic, but will that actually reflect what the user wanted or what the user anticipated? That especially comes into play when we start talking about text-based CRDTs for like real-time typing collab. Because if you're typing on one sentence and then someone types in the middle, what do you expect to happen? Do you expect those words, those letters to be interleaved? Like, no, you expect one person's sentence and then another person's sentence. And yeah, they might be together, but they shouldn't be interleaved. So both of those outcomes, interleaved or contiguous, are acceptable, but one is more aligned to user expectations than the other.
Yeah, that's essentially, you said it really well. That's what I was trying to kind of say earlier, is that, yeah, maybe you want people to, yeah, you don't want stuff to interleave, but there are edge cases where it's really weird, right? Like if they start typing at the exact same cursor position or something, right? You probably but maybe you should be interleaving it, right? Like it's just, you can only really guess at some point, right? Like when it gets really contentious.
Yeah, and I think that's where, the CRDTs, at the very least, they give you that is consistent and that you can rely on. Whether it is convergent, which is really critical. But beyond that, they're only so magic. I mean, they solve a lot of problems, but they don't solve all the problems, for sure.
I think that's what I was just trying. I don't think you could even describe what would be correct. Like, not even just not describe. There is just no correct way.
I think there are obviously incorrect ways, but perhaps no obvious right ways. Both of these examples that I've shown are in the repo, so the source for them is runnable and people can take a look. I would love feedback if people build on it. That would be awesome.
Any other parting thoughts, ideas, calls to action?
I said it earlier, but I'll say it again. I really do like the Gleam community. And, if any of the things that we've been talking about today are interesting, the Gleam community is probably a good place to join and participate in and everything. So, and I guess the last thing I would say is that community that I mentioned, CRD, it's new, but I think it has a lot of potential specifically for groups like this, or like the Gleam community, groups around a technical area that need to share both in real time, but also have some connection back to, like a repo or some place that isn't just the community itself. So yeah, I'm excited to start using it more for communication with people that are using Beryl. So.
Thank you so much.
Yeah, thanks a lot. Really interesting stuff.